Hello and welcome to Medha Care. So without wasting time, let us start today's session with this question. In this question, we have to find out the most stable diene. So generally, for alkene, we consider the hyperconjugating structures. But in this case, we have one more factor, that is conjugation. So as you know, the conjugated dienes are more stable. So that's why the answer in this case will be 2, because here you can see double bond, single bond, double bond. So there is conjugation between these bonds. That's why this one will be the most stable one. So in this question, we have to find the product when X on hydrolysis followed by polymerization gives. Now see, first we have to check what is X. So when silicon tetrachloride RCl4 react with two equivalent of Grignard reagent RMgCl, then we get R2SiCl2 plus MgCl2. So only two chlorine atoms will be replaced by the alkyl group. Now, if we hydrolyze this one, after hydrolysis, we get this silanol. Now, if you see the structure of this silanol, it contains two OH groups. Similarly, if we write another one, now if you remove water, as you can see, we are getting a linear structure. Okay, so this is linear silicon. So in this case, the answer will be 1. So it will be linear silicon. Let's see question number 3. Very, very important question. See, in this question, you have to find which of the following compound will not undergo Friedel-Crafts reaction. So in this case, you know that haloarenes do not undergo Friedel-Crafts reaction as Rx. Remember that one. They do not undergo Friedel-Crafts reaction as Rx. At Rx, you cannot take that one as aryl halide, as carbocation is not possible in this case due to partial double bond character. But they can undergo Friedel-Crafts reaction as benzene ring. For example, if you take chlorobenzene and if you do the reaction with CH3Cl in presence of anhydrous AlCl3, you will get ortho and para derivative. This is Friedel-Crafts reaction. So now see, in this case, what we have seen? This case, chlorobenzene can undergo Friedel-Crafts reaction as benzene ring. But if you consider that one as Rx, then it will not undergo. But the question here, it is clear that chlorobenzene can undergo Friedel-Crafts reaction. Okay, so this will not be the answer. Now, in this case, the answer is 3. So why the answer is 3? Because if you take aniline is a base, Lewis base. When we add AlCl3 in this case as catalyst, AlCl3, it will act as Lewis acid. So they will form acid base adduct. That Lewis acid base adduct. So the catalyst that we are using here, it is act as Lewis acid and consumed in this step. That's why the reaction will not occur. Again, you may take AlCl3 excess, but in that case, it will also not react, because when the nitrogen gets positive charge, it acts as electron withdrawing group. So it will withdraw electron from benzene ring in such extent that it will not further react in Friedel-Crafts reaction. So that's why in this case the answer will be 3. So remember that one. It is very important question. You may make a mistake here to with the chlorobenzene or with aniline, but remember that chlorobenzene can undergo Friedel-Crafts reaction as benzene ring. Okay, I hope it is clear to you. Next, see question number 4. Question number 4 already we have discussed in previous videos, that if Grignard reagent contains, if we have Grignard reagent and if we have any kind of proton source, then it will become RH, hydrocarbon we will get. So in this case, trimethylamine does not give ethane with Grignard reagent because it does not contain any acidic hydrogen. So statement 1 is correct, and statement 2, if you see, it is the answer that it does not have any acidic hydrogen. So statement 2 is also correct. So both the statements are correct in this case. Now see question number 5. Question number 5, the most basic compound in this case. Most basic compound. So one point you have to remember, that in case of nitrogenous bases, if you are asked to find the basic strength of nitrogenous bases, so first what you have to do, first you have to check the hybridization of the nitrogen atoms. So this is the first step you have to do. So check nitrogen hybridization of the nitrogen atoms. So in this case it is sp2, and second case it is sp3. This case, this nitrogen is resonance stabilized with the CO group, so this is sp2 also, because otherwise it will not participate in resonance. So in this case, this nitrogen lone pair also conjugate with the benzene ring, so that's why it will be also sp2. So always remember, if more s character, that means more electronegativity. So I write here more s character, that leads to more electronegativity of nitrogen atom, and if there is more electronegativity of nitrogen atom, then it will be less basic in nature. So in this concept you can clearly see that 3 is the answer, because in this case nitrogen is sp3, in all other cases nitrogen is sp2. But you can solve this problem by remembering this one also, that aliphatic amines, then aromatic, and then amides. But if you have amidine will be the most basic one. So that is the order: amidine, aliphatic amine, aromatic amines, and then amides. So in this case you can see this one is aromatic amine, this one is aromatic amine, this one is amide, and only aliphatic amine that we have is this one. So that will be the answer in this case. Thank you very much for watching. If you have any question, you can directly send me to this mobile number. We have a good news for you also, that we are starting new batch at College Street this year. Okay, so keep in touch with us, save this number, and check our WhatsApp status for further details. Thank you very much.